Hello there, this is Haddad here again. Let's start directly doing the lab of the hello package. So we have this lab over here, many points to pass through, and then we're going to do it point by point. Before we start, I just want to show you about the lab scenario, which is the same one as we were working in the previous lecture. We have router 1 connected to router 2 on their Ethernet 1 interface, and they are on the subnet of 192.168.12.0. Router 1 has .1 and router 2 has .2. Both routers will be configured inside the area 0.0.0.0, which is the backbone area. So let's see what we have to do now. Point number 1. All IP addresses are already configured on the picture. Okay, so I have already configured the IP addresses as on the picture, and I have already put the picture again on top of my head so you can follow what we are doing. Point number 2, ping from router 1 to Ethernet 1 of router 2. Do you have a reply? So now we are just trying to check if we have configured the IP addresses correctly. Let me go to router 1, and from here I have to go to new terminal, and I say ping 192.168.12.2, and we can see that I'm able to ping from router 1 to Ethernet 1 of router 2. Okay, so this step is also done. Number 3, configure OSPF on router 1 and advertise the connected network. So we need to enable OSPF on router 1. I will put router ID 1.1.1.1, and then we will advertise the connected network, which is, we have only one network now, which is 192.168.12.0. Okay, I will go to router 1, and from here I will go to routing, OSPF. In instances, we can, let's lab, we create a new instance, but what you can do is just you can double click also on it, and then you can put 1.1.1.1. That's the router ID. I want it to be the default. And then I have to go to networks, and I will advertise the connected network, which is 192.168.12.0/24, and it will be on the backbone area. So this is just like a review about what we have done in the previous lab. Okay, so we have done this, that's fine. Point number 4, configure OSPF on router 2. We will give it router ID 2.2.2.2 and advertise the connected network. Also, we will do that. And then they said enable OSPF on Ethernet interface, Ethernet 1 interface only. Okay, so it's similar to what we have done in the router 1, but here we just need to enable OSPF on Ethernet 1 interface only. Let's go directly to router 2, and then again I go to routing, OSPF. Here I will put the router ID 2.2.2.2, and then on the network I will enable 192. I will advertise 192.168.12.0/24 inside the backbone area. And the third point they ask us to do is to let the OSPF work on Ethernet 1 only. Okay, so what we can do, we can just create here a new OSPF, and then here I say I want Ethernet 1 to have OSPF enabled on it only. Apply and OK. Okay, let's see now if we have neighborship, and you can see router 2 has just formed neighborship with router 1. We can see the router ID over here, and these are the LSA that was received. Okay, so this point is done. Now the question is, why do we need to enable it on Ethernet 1 interface only? Because this is needed for the rest of the lab. We are going to work on the interface Ethernet 1 to change the hello package. Point number 5, check if both routers form neighborship in OSPF. And we have just seen that they have formed neighborship, so that's fine. Point number 6, change the hello interval on router 2 to 12 seconds. Remember we said that the router always sends a hello packet every 10 seconds, and it has a dead interval of 40 seconds. Okay, and that's to be able to form the neighborship. And this needs to be matched in order for the two routers to form the neighborship. Now they're asking us here in point number 6 to change the hello interval on router 2 to 12 seconds. Actually, it's on the Ethernet 1 of router 2. Okay, because the Ethernet 1 is the one which has the OSPF enabled on it. Let's go directly and change it and see if we will have neighborship. I will go to router 2. In interface here, interfaces, I will go inside Ethernet 1. But before, I just wanted you to check. We already have now the neighbor. It's working, no problem. We have seen it. Now I will go inside Ethernet 1, And here you can see that the hello interval is 10 seconds and the dead interval is 40 seconds. Before I make the change, I will go also to router 1, okay, and also here you can see that the hello interval is 10 seconds and the dead interval is 40 seconds. That's by default on MikroTiK. 10 is the hello, 40 is the dead interval. Let me go back to router 2 to make the change. I will put it now 12. Okay, the hello interval is now becoming 12 seconds. And when I say OK, we check the neighbors. You can see it has directly removed the neighborship because the hello interval doesn't match with router 1. If I go now to router 1, and we can see that it's still having the neighbor with router 2 because it has to wait a little bit. Remember, it has a dead interval of 40 seconds. So it's not yet 40 seconds to be able to take it out from its neighbors, okay, the table here. So, but in a moment, a few seconds, you will see that it will also be, you see it's down now, state is down. And in a moment, you will see that we don't have neighbors. You see, it's finished. No neighborship anymore with router 2, okay, because we just changed the hello interval. So do the router have neighborship? No, they don't have. So this point is done. Point number 7. Change the hello interval on router 2 back to 10 seconds. Is the neighborship formed again? Let me go again to router 2. We will do the reverse what we have done in the previous point. This is router 2 now. I will go to interfaces, to Ethernet 1. It is 12 seconds. Let me put it back 10. And then I will say OK, and I go to neighbors. And we shall see in a few seconds that the router 2 will be forming now neighborship with router 1. You can see it here directly, and they started sharing LSAs, and everything is fine now. Because they have the same hello interval now. Also, if we go to router 1, we can see the same. This is router 1 now. I have neighbor with router 2. This is the router ID of router 2, and here are the LSAs. Okay. So point number 7 now, it is done. Is the neighborship formed again? Yes, it is formed because they both have now same hello interval. Create an area 1 on router 2 and put its Ethernet 1 interface on this area. So what we are now trying to do also to check inside the hello packet, if we change the areas, like we put one router on one interface on one router in an area, which is connected to another interface of another router, but it's on another area. Okay, so in this case, we will put Ethernet 1 of router 1 on area 0, which is now on area 0, but we will change the area on Ethernet 1 on router 2. They are both connected to each other, they are both on the same subnet, but they are on two different areas. And we have seen in the previous lecture that if the areas are not the same, they cannot form neighborship. So we are going to do now this and see if we put Ethernet 1 of router 2 on area 1, not the backbone area, if they can keep having neighborship or not. So the point is to create an area 1 on router 2 and put Ethernet 1 interface on this area. And then we see if they lose the neighborship. Okay, I will go now to router 2. This is router 2 now, and then I will have to create a new area. We have this is the backbone area. We'll make plus, and I will call it area 1. Let's give it an ID, for example, 11.11.11.11. Just to not mix with the router ID of 1.1.1.1. You can name it whatever you want. Okay, and we keep the instance the same, and then I will say, okay, so this is area 1 is created. Now what we need to do, we need to put the interface Ethernet 1 or the advertised network that we have advertised inside this area. To do that, I will go to networks. Remember here, when we advertised this network, we said we put it in area backbone. Now, what I want to do, I want to put it in area 1. Okay, and I will say, okay, and let's directly check the neighbors here is gone on router 2 directly. If I go to router 1 and I'll put on neighbors, it's still there, but again, remember that it needs some seconds, and in a few seconds you will see that it will go off. So now we see it is down, and in a few seconds we will see that it will remove it directly from the neighbor table. And that's another proof also that if you have two interfaces connected to each other, each one of them is on an area, then in this case they will not form neighborship. Okay, let's see what we have to do, the upcoming points. Number 8, we have created the area, we put Ethernet 1 of router 2 on this new area, and we've seen that the two routers, they lose their neighborship. Okay, point number 9. Put again Ethernet 1 interface in area 0 and check whether R1 and R2 form neighborships again. So again, we have to go to router 2. We see no neighbors now. I will go to networks and I will just say I want to put this inside the backbone area, which is the same area where Ethernet 1 of router 1 is connected to. And then I'll say OK, and on neighbors we have to look now. In a few seconds it's gonna have neighborship, and here we go. You can see that this router 2 has now formed neighborship, OSPF neighborship with router 1. And if we go to router 1, now this is router 1, and we see it has formed neighborship with router 2. Okay, so point number 9, we have put Ethernet 1 of router 2 again on area 0, the backbone area, and we've seen that they have formed neighborship again. The last thing we need to do is to play with the authentication. Also remember when I said that authentication, if we change the authentication on one of the routers, even though they have the same hello and the same dead interviewer and they are in the same area, but if you change the authentication, then in this case they will not also form neighborship. They are asking us here in point number 10, change the authentication in router 2 from none to simple and put a password 123456. So at this moment, both routers, they don't have authentication, so there is no password in any of the two routers. That's why they can form neighborship directly. That's by default. But MikroTiK allow us to put a password inside the OSPF. And in this point number 10, they ask us to change the authentication and put it 123456. So now I'm in router 2. Inside router 2, I will go to interfaces, and inside Ethernet 1, you can see over here the authentication at this time is none. That's why we have neighborship. So if you look here, we have neighborship. And also on router 1, we have the same thing. Okay, we don't have authentication. So what we need to do now, we have to change the authentication from none to, we can put it MD5, we can put it simple. We will discuss about authentication later in this course. But let's just put it simple, and I will give it the key or the password 123456. Okay, and the key ID we will keep it 1, and we say OK. And now you see directly neighborship has gone on router 2. If we look again on router 1, we still see the neighbor with router 2, but in a few seconds it will also go away and it will be down. Okay, we wait a few seconds just to see it also on router 1. So now we see that it has stayed down, and in just a few seconds it will take out the neighbor's router 2. You see it now is gone. Okay. So point number 10, we changed the authentication and we put a password 123456, and did the R1 and R2 lose the neighborship? And we've seen yes, they have lost their neighborship. So this is the whole lab that I wanted to show you. Before I finish it, let me just take the password out from router 2 again and see if they can form a neighborship after we take it out. So I'll put none here and no password and OK. This is router 2, and it shall now have a neighbor with router 1. And here we go. Okay. So this is what I wanted to show you in this lab. This is really a detailed lab of OSPF hello packets. I hope that you enjoyed it and you found it informative for you, and I will see you in the upcoming lecture.